Let's look into normal distributions since we are talking about binomials, and normal distributions are the one where are kind of, standards where we try to compare every distribution with it and then try to see whether we can fit in those normal equations or we cannot fit in those equations. So a normal distribution is also known as a Gaussian distribution, is a continuous probability distribution. So you have a continuous kind of, values where you have continuous grades or shades. So values, actually the data is not coming from discrete outcomes. You can have like weight data, you can have lengths, masses, anything. Commonly this distribution is observed as a bell shape distribution. So here are some properties of this distribution. It is bell or mound shaped. It's symmetric around the mean. So towards the right and towards the left, the right hand side looks like left hand side. So that property we call it as symmetry. Theoretically, it goes from negative infinity to positive infinity. So actually, on the y-axis, we see that the lines they are kind of become parallel, and it goes and it continues. A mean of this distribution is 0, and standard deviation is 1. Actually, this idea is associated with a graph with the distribution which we call it as z distribution. So it is represented by that formula. So as per that formula, we can plot those z values under this curve. So because of that, we say that its mean is 0 and standard deviation is 1. So here is this distributions, guys. So we have mean in the middle, represented as mu. So mu here is, guys, population mean. So we are talking about a population. So generally, ideally, we see that populations are distributed like this. Most of the data in this world is distributed as this normal distribution. So if we move around mu plus 1 standard deviation away towards the right and towards the left, so we can have these much amount of values. We look into, there is one rule, we call it as empirical rule, how many values are there. Then we can move around this mean. So we can move in terms of standard deviation. So this distribution, like every distribution, has a mean which is represented as mu, and there is a standard deviation. So we have seen that in earlier formulas where we have seen that mean is average and of those numbers, and the standard deviation is observed from taking the square root of the variance. So we have seen that before. So this is the standardized value or score as far as this distribution is concerned. We call it as z-score. So it is given by any observation y minus mu divided by standard deviation. So if we play with this equation, we can have this z-scale also. So any distribution can have a z-scale also, where the z is the mean of this. If we take it, it's 0, and here is 1, and here is -1, and here is -2, and towards this side is +2. So that actually we are moving 1 standard deviation away from that mean, and we are putting that in this equation, and we are getting this scale. So anything under this curve has a value, has a number associated with it, and that number is also there is one number coming from this z distribution also. We will use that when we will do these statistical tests, normally when we talk about the expression data. So just keep it in your mind, this equation. As per empirical rule, if we take a standard normal curve or a normal distribution, there is a mean in the middle. We have seen that before. Here we are 1 standard deviation away, here we are 2 standard deviation away, and here we are 3 standard deviation from the mean towards right side. Same way we can have these towards the left side, or the values which are less than mean. So 68% of the values, guys, that is 1 standard deviation away from the mean. So this is 68% the values in the middle. We add 13.5% more towards right and left. So in this way we can have 95% of the values which are 2 standard deviation away from the mean. If we move 3 standard deviation away from the mean, the values are 99.7% of the data are within that I said. So here, just to give you a brief idea where we're gonna use it, if we observe some numbers and we want to know if these numbers are significant, or they are significantly different from rest of the group, we would probably be looking into those numbers falling here, somewhere here in those tails. Another way around, this is our, we can say, upper 2.5%, and this is lower 2.5%. So these are the extreme values. So when we talk about those statistical tests, we'll talk about these extreme numbers and these tails of these distributions. So in this section, we have seen that normal distribution is a continuous probability distribution, which is symmetric in shape.